Having labeled our data using CVAT, now let's move on to model training. So how to use YOLO 8 for custom object detection, and for that we are going to use an YOLO 8 version from Ultralytics. If you go to the CLI documents, it tells you what are the command that you need to write to do the training. So you see, you just copy one line of code and then you are ready to train your model. And then there are lots of things that you can do here. So for example, if you could go to uh, um, arguments, so there are many arguments. For example, the normal syntax is type YOLO, then task, so it is like you want to detect, you want to train, you give a data. So you need a YAML file, configuration file for your YOLO, that we will see shortly how to prepare it, and then give it a model upon which you want to train it, and then you are ready to go. So normally the syntax is or if you go to this configuration page, you can see a lot of arguments that can be passed for training and for detection. So I would suggest you to look into this. For example, this model, it takes the model or a YAML file that we will prepare shortly, then data, what you want to do that. So epochs, how many epochs do you want to train? Default is 100, but you can change it. So time, how long do you want to train it? Patience is something very useful, that for example you give it a for you train it for 500 epochs, and then you see that that after 100, after x epochs or after 50 epochs, they are not changing. I mean, the loss is not changing much, so you can just break it early. So that is what patience come into with. This is the batch size, and then this is what you want to look into this. So once you have the detailed overview of what are the arguments that can be passed, so we are ready to run our training. So but to run this code, or to run this train, what we want to do is that we want to create a YAML file. To create a YAML file, let's go to our base folder where we have our dataset. Here, create new and give it a name. vehicle-detection.yaml. So and hit enter, and then copy this, sorry. So we have to copy this, so copy this into your folder. So what this really says is the following. So if you look into the folder structure, sorry, not virtual environment, if you look into this folder, what it says is that this YAML file is here, and then it says that you have to give a path to your training folder. So my train is here, so give the path to your train image, and similarly your val image, and then your test image. So give it a path here, and then you have number of classes. How many classes do you use during your labeling? So it should be that number of classes. We used 5 classes, so 5. If you have 2, just use 2, and then you name them. So and then one thing here is that the naming here should be the same in sequence as you used for your label. For example, you used ambulance first, then it should be ambulance here. If you used bus first, then it should start with the bus. The idea here is that the labeling sequence and the names should match, and if there is a mismatch, you might have error, or you will get poor detection. So just save it and close it, and now we have our, this is how our folder structure look like. So you have an YAML file, and then you have your data here. So now we are in a position to uh, type or to train. So first thing, we will want to go to this path, then yeah. So now we are in my base folder, then type yolo task is equal to detect model mode train epochs 50. I want to train it for 50 epochs just for demonstrations, but you would want to train it for at least 100 or 200 epochs to get good results. So data, so then you have to use your YAML file. So vehicle-detection.yaml file, and then model is yeah. And what is this model? So we have explained all those things, but model here is this thing. If you go to your git, so as we discussed here, so these are the model. So you can pick any one of these you want to train upon. For example, YOLO V8 a small, medium, large, and X, and then N. So this is one that has like least number of parameters, so that means it would be easy to train, but it has like lower accuracy, so mean average precision is lower as compared to others one, but it is lightweight model. It has only 3.2 million parameters, so it would be faster to train. If you use others, it would take a longer to train, but you would get a good accuracy. So there is a trade-off between accuracy and computation power. And then and then the pixel size standard is 640. Again, I would ask you to go to this configurations file, and then choose what you want to pass in your command line. So basically what we are doing is that we are YOLO task mode and arguments. So this is the syntax: task mode and arguments, and this is what I'm doing. Task detect YOLO task detect mode train, and all the others are the arguments that it takes, but these two remains the same. And then if everything is all right, then we should train our model and hit enter. It would take a while to run. Let's see. Yeah, so now it has started downloading. So it downloaded YOLO V8N. Yeah, so now, yeah, so when you see these kind of things, activity going on in the terminal, that means you are good to go. But see here, what it does is that it downloaded YOLO 8n.pt. So if you go to here, so now you see the new model has been downloaded. So this is the model that has been already trained upon, and we are using this model to, and this data in this train and validation upon this model to have custom detection of the object. And you see, when this training runs, then you get a new folder here runs, and then detect train, and it should contain all the information here. So while it's training, let me see. Yeah, so while it would take a while it's training, I will pause the video and be back when the training is done. So up to 50 epochs, it would take a while. I already have done it, and then on CPU it takes while. Yeah, so I'll pause and I'll be back when it's done. Yeah, I already have done the training. I interrupted it earlier, so um, just to show that that the training was done. So instead of training for 50, I just trained for a few epochs, and then just to show you that okay, we have some model running, we have some model here. So then after running, if you go to our folder, so we have this new folder runs coming here, detect, train, and then you have your all the results here, and then results will be here, and then the weights. So what we need is this best, so last and best, so choose for the best weight here. So and then once we have these results already here, and then we have this Excel file also, that gives you the list of your errors. For example, if you want to plot them differently, though you get some PNG curve here, though this gives you a PNG curve here of the different losses, so like training loss and precision, recall, matrices like at mean average precision at 50 to 95, and then losses, class loss, and all those things, so if you want to have this plot by yourself, what you can do is that all the results are in this Excel file. And then you can just plot. For example, if you want to plot it yourself, just take this data, and then you can plot it by yourself. You see, you can plot it by yourself, or you can do smoothing or whatever you want to do it. So if there is a selective, only if you don't want to give all the results, only selective results, then you have a data here, and then you can use it to plot it yourself. And but to do the detection, we need this model. And then we are done with this training. And then once you run all this successfully up to this process, then you are ready to go with the object detection. So in this session, or in this tutorial, we saw how to train a model, and next we will do model testing.